Okay, on this 13.5 worksheet, I'm just going to go through the odds here rather. We'll start with number 1. First thing I'm going to do is trying to solve for cosecant there. So I'm going to add my 2, and then I'll divide by the square root of 3. So add 2, divide by square root of 3. So I get that cosecant of x is 2 over square root of 3. I'm not going to rationalize it, but I'm also going to change it from cosecant to sine. Cosecant is the inverse, or the reciprocal rather, of sine. So I would just reciprocate the fraction. And now I've got a sine equation that I can deal with. Now it says the general solution. Okay, we'll keep that in mind. I'm going to draw the picture. Now this is a sine problem and it's even. Sine is even in quadrants 1. And it's also even, or odd, positive is what I'm trying to say. It's positive in quadrant 1 and it's positive in quadrant 2. In the other quadrants it's negative, so I don't want those quadrants. Okay, so sine is opposite over adjacent, or over hypotenuse. So opposite square root of 3. Hypotenuse is 2. This is a 30, 60, 90 triangle. And opposite the square root of 3 is 60 degrees. So I have 60-degree reference angles here. Now, I'm going to go ahead and put it in terms of pi. 60 is 1/3 of a pi, or so pi over 3. So one of my answers, since it's in the first quadrant, is pi over 3. Because it's going to then repeat every 2 pi, I get back to that same point, every 2 pi, I'm going to add 2 pi k, so that it's a general and allows for the coterminal angles. It's the general solution, allows for all the coterminals. But then I also have another one that's really over here at 120 degrees, or it's 60 degrees shy of a pi. So 1/3 pi shy of a full pi. That means it's 2/3 of a pi. So 2/3 pi radians plus 2 pi k to make it a general solution. And there are our answers for number 1. Number 3, I'm going to add my 4, divide by 3. Of x there. I'm going to square root it. And anytime we square it, we have to do plus minus. So plus minus, when you have square root of 4/3, square it the top and bottom separately. So square root of 4 is 2. Square root of 3 doesn't simplify, so it's simply square root of 3. Now since it's secant, I'm going to switch it, I'm going to flip it to make it a cosine. So positive and then negative square root of 3 over 2. Let's draw a picture. Because it's plus and minus, I want everywhere that cosine is positive and everywhere that cosine is negative, which means I'm going to use all 4 quadrants. Because cosine is positive in quadrant 1, and it's positive in quadrant 4. So I get these two. So opposite is 1, or sorry, I want adjacent rather. It's cosine. Adjacent is 1, and your hypotenuse, adjacent was square root of 3, not 1. Keep misspeaking here. Adjacent is square root of 3. So then the opposite would be 1 and negative 1 if we needed to write that, but my hypotenuse is 2. Now I also have a negative. So cosine is negative in quadrant 2 as well as in quadrant 3. And so there, my adjacent would be the negative square root of 3, while the hypotenuse is 2. So these are 30, 60, 90 triangles. And it's the 30-degree angle, which is pi over 6. So I want pi over 6 in the first quadrant. To make it general, I'll add 2 pi k. In the second quadrant, I want a full pi minus that 1/3, or 1/6. So that's 5/6 pi. 5 pi over 6. Plus 2 pi over k, or 2 pi k. In the third quadrant, I go a full pi plus a 6. That's 7/6 pi plus 2 pi k. And then in the fourth quadrant, that's almost a full 2 pi, but it comes a 1/6 short. So that's 11 pi over 6 plus 2 pi k. So there are my general solutions for number 3. Number 5, I'm going to add my cosine of x over. So to read 2 cosine squared of x plus cosine of x equals 0. I'm going to factor out cosine from both sides. Cosine of x is equal to 2 cosine of x plus 1 equals 0. Now set each factor equal to 0. So we'll set cosine of x equal to 0. We'll set 2 cosine of x plus 1 equal to 0. The first one's already solved. It's going to be a quadrantal because it's a cosine of 0. Cosine, we remember, is the x value. Sine is y, cosine is x. So we have an x value of 0. So think about your unit circle. Which has points, which quadrantals have points of with an x value of 0? Well, that would have to be up here and down here. So at pi over 2, this one's not, it's not asking for general solutions, so just pi over 2, and then also at 3 pi over 2. Those would be solutions. Now I also have to solve this one. So if I solve this problem, cosine of x, I have to subtract the 1, and then it's over 2, so it's negative 1/2. So we want cosine negative. Cosine is positive in the first quadrant. It goes A, S, T, C. So it's positive in quadrants 1 and 4, so we want negatives in quadrants 2 and 3. So our adjacent is negative 1, our hypotenuse is 2. So 30, 60, 90 triangle, we're looking at a reference angle of 60 degrees, or pi over 3. So the first one, if I come over here from 0, if I made it all the way to 180, that would be pi, but I came with 60 degrees shy, so I'm really at 120. So I'm a third of pi short of pi, so that's 2/3 pi. So I have a 2 pi over 3 as an answer. And then we go down to the third quadrant and go full pi plus another third, so that's 4 pi over 3. So there are all of the solutions to that equation within that interval 0 to 2 pi. Number 7, I'm going to go ahead and add or subtract my 1, and then I'll divide by negative 2. Subtract 1, divide by negative 2. You notice it becomes a negative over negative, so we're going to have a positive. Then I have to square root. It's plus minus. So plus minus, square root of 1 is 1, so my numerator simplifies to 1. Oh, sorry, you can't see. I apologize for that. So catch up, I added my 1, or I subtracted my 1 divided by negative 2. They both became positive. Square rooting, so we get a plus minus. So now, square root of 1 is 1. Square root of 2 doesn't simplify, so it's simply square root of 2. So since it's a plus minus, we're going to look at all 4 quadrants again. So the reason I have all 4 quadrants is because positive sine's positive in quadrants 1 and 2. So my opposite would be 1 in both of those cases with a hypotenuse of square root of 2. You'll see I drew my picture. My picture is not drawn to scale. It was actually a 45, 45, 90 triangle. So don't worry about the fact that my picture is not drawn right. It doesn't matter. Sine's negative in these 2 quadrants, so my opposite would be a negative 1. Square root of 2, square root of 2. So my reference angle in these problems is 45 degrees, or pi over 4. So the first angle is 45 degrees, so pi over 4. The next one, I'm stopped pi over 4 shy of pi, so that's 3 pi over 4. And then I go up to a pi plus a fourth, so that's 5 pi over 4. And then lastly, I go to the full 2 pi minus a fourth, so that's going to be 7 pi over 4. And then lastly, number 9. I see I've got a cosine and a sine, which isn't really a problem. I don't want different ratios. So I'm going to use my trig. I have a cosine squared. I'm going to think about the trig ratio. I'm going to kind of write it off to the side over here. You don't need to write this part down probably, but I want you to understand why I'm going to do what I'm going to do. So we know this to be true. I want to solve this for cosine squared. So to do that, I have to subtract away sine squared. So what I know, and this is what I'm going to use, that cosine squared is equivalent to 1 minus sine squared. I'm going to substitute 1 minus sine squared in place of cosine squared here. That way all I have are sines. So I have a 2 up front, then write in 1 minus sine squared of x. Okay, so I substitute that in, then continue the equation, plus sine of x minus 1 equals 0. I've got to distribute the 2. So 2 minus 2 sine squared of x plus sine of x minus 1 equals 0. Combine like terms. The 2 and the negative 1 can combine. So we have negative 2 sine squared of x plus sine of x, and then 2 and negative 1 make a positive 1. So plus 1 equals 0. My lead term there, because it's going to be a factoring problem, my lead coefficient is negative, and I don't want that negative. So I'm going to actually switch all my signs here. So I'm multiplying both sides by a negative 1, essentially. So all my signs switched. Now I'm ready to factor. So because it's a 2 sine squared, I know I'm going to have a 2 sine x and a sine x. Because my last term is a negative 1. One of them is going to be a positive 1, one's going to be a negative 1. Let's just put 1s for a moment. This one, the second one, it's going to get multiplied by a 2, so it'll make a 2 sine. In the middle I'm going to have a 1 sine. And I want them combined to make a negative. So I need the bigger one to be negative. So the 2 sine will be negative. So this second one's got to be negative. The other one's got to be positive. So one of my parentheses should say sine x minus 1. The other should say 2 sine x plus 1. Now, I may run out of room on this problem, but set each factor equal to 0. So sine x equals subtract 1 divided by 2, so I get negative 1/2. Let's go ahead and I'm going to draw that picture small. Sine is negative, so I'm looking at quadrants 3 and 4. Okay, opposite is negative 1, hypotenuse is 2. It's a 30, 60, 90 triangle. It's 30 degrees, which is pi over 6. But it's in quadrants 3 and 4, so we got 180 plus 30, that's 210, or really pi plus a sixth of pi. I'm going to write my answers over here. So it's going to be 7 pi over 6. On this one, I'm going to go full 2 pi minus a sixth, so that's 11 pi over 6. Now in that second problem, sine x minus 1 equals 0. So sine x equals a positive 1. That's a quadrantal. Sine is the y value. Think about your unit circle, and where on that unit circle the y value is a positive 1. That would only be up here at 90 degrees, or pi over 2. So those right there are the answers to number 9. All right, hopefully that helps and that you can work your way through the evens.